Okay, welcome to my YouTube channel again, and today we're going to be discussing about algebraic expressions and algebraic formulas. Let's get right into the video, and let's start with what's a polynomial. So as you can see, a polynomial is a mathematical expression which is made up of variables, coefficients, and exponents combined using addition, subtraction, and multiplication. The variables in a polynomial have non-negative integer components. So, as you can see in the example given in here, there is a 3x squared plus 2x minus 5. Now, let's see what's a coefficient and what are exponents and what are variables. Let me just grab a pen and I'll get right to it. Okay, so let me write the expression again. So it's 3x squared. Okay, and then there is plus 2x, and then there is negative 5. So do we see that there are any negative exponents? Well, exponents are basically these wait a second. Okay, so the thing that I'm marking in green, this is actually the power. So this is an exponent, right? This is an exponent. I'm writing it down with an E. Now what's a coefficient? Well, coefficient is something that is attached to the variable. The variable in this instant is x. Here x and then here x. These both x's are variables. And when you talk about 3 and 2, these two are coefficients because they are attached to the variables, right? So that's what's a polynomial. Now let's see what a polynomial is not. Let me erase everything first. Okay, so everything is nicely erased now. Okay, now let's get to what is not a polynomial. So an expression that is not a polynomial typically has one or more of the following features, which means it does not have any negative exponents. For example, if I say this is a number 2x and there is a power -1 on x, then this thing would not be a polynomial. If this term is in any polynomial, the whole expression would not be considered a polynomial. Okay, fractional exponents. So for example, you have like 2x and then plus y raised to the power 1/3, and then there is plus root 2. For example, this is the expression. You can see that y has an exponent which is in fractional terms. 1/3 is a fraction, right? So this expression would not be a polynomial. Variables in the denominators. Okay, let's see an example of that as well. So if there is an expression like 3x upon x plus 2, and then suppose we just subtract 9 from it, then you can see in this expression, in this whole expression, there is one term, or well, we cannot call it a term, but x plus 2 is in the denominator. There is a variable in the denominator. X is a variable, right? So this whole expression would not be considered a polynomial. Then we have non-integer exponents, right? So what are non-integer exponents? Well, anything from negative to positive numbers are integers, right? So if there is an exponent other than these integers, then we would not consider it a polynomial. Roots of variables, like if you see a root x or a root xy or root z, that thing will not be considered a variable. I mean a polynomial. Products of variable. If you just see a single thing like x dot y, what do you think this is? Is this even an expression? I guess this is just one term, this x dot y, because it's a multiplication of x and y, right? So it is a product of two variables. This will not be a polynomial. Now let's see if we can identify if the following expressions are polynomials or not. Okay, let's go. Let me just erase everything here. Okay, nice and clean. Okay, the first expression, as you can see, 3x squared plus 1 upon x minus 5. Let's look at the terms. Let me just write the expression in here as well. And let's check if this is like, getting it. If this is a polynomial or not, or if it's even an expression. Let's look at that. Well, it is an expression, sorry. This is our expression. Now let's check. Does it have any negative exponents? Well, I don't see any negative exponents. Are there any fractional exponents? I don't see that as well. But is there a variable in the denominator? Yes, we do see an x in the denominator, which makes it not a polynomial. Now, are there any non-integer exponents? Well, nope. Are there any roots of variables involved in here? Well, not. And are there any products of variable in there? Well, also not. So this whole term is just an expression because there's a variable in the denominator, which makes it just an expression and not a polynomial. Now let's look at the second expression. I'm going to erase this one here, and let's get to the second one. So we have 3x cubed minus 4x squared minus x root x plus 3. Now let's see if we if it fulfills the requirements. So I'm going to write this down as well. 3x 3x cubed minus 4x squared minus x root x plus 3. Wow. Did you see any negative exponents? I do not. Any fractional exponents? Well, if you do open this x in here, this x will become like this. X product of x 1 upon 2, because a root means a power of half. So, oh. Sorry. Well, let's leave it. So, it becomes a power of half in here. And are there any variables in the denominator? I don't see any. Are there any non-integer exponents? I don't see that as well. Roots of variable, yeah, well, I do see x in a root. And are there any products of variable, like just the product of variable? Well, no. But yeah, x dot x is a product. Okay, let's continue. So, there are two expressions written in here. Let's cross-check if they meet the requirements of a polynomial or if they do not meet the requirements of a polynomial. So, in this expression written in dark blue, x squared minus 3x plus root 2, do you see any negative exponents? Well, I do not see any negative exponents. Are there any fractional exponents? Well, on the variables, I do not see any fractional exponents. Are there any variables in the denominator? Well, I don't see that as well. Any non-integers integer exponents? Well, nope. Roots of variables? Well, there's a root of a number, but there are no roots of like actual variables, right? So, and are there any products of variables? Well, there is not just like a single product of a variable. So this will be considered so this will be considered a polynomial. Meanwhile, if you look at the other expression that I've written in here, okay, so we have 3x upon 2x minus 1. There is a variable in the denominator, like there are 2x minus 1, where x is a variable, right? So because of that, unfortunately, this expression is not a polynomial. Let's check. Okay, well, let me just clean everything down. We looked at 4 expressions. I'm going to show you every one of these. So this has a variable in the denominator, which means this won't be a polynomial. This has a root over a variable. No, so this won't be a polynomial as well. This will be a polynomial. And this won't be a polynomial. I will try to find some exercises for you guys, and in my next video I'll post those exercises in the description. Thank you so much for watching. Let's meet again.